Welcome to the Math Record. Today I'll be covering the ICTM Regional 2017 Division A Algebra 1. Okay, let's start. So the first question is 4m cubed plus 3m squared minus m plus m squared plus 4m minus 2, which is equal to km cubed plus wm squared plus pm plus q. And then you have to determine the sum, which is just adding all the coefficients. So generally for this type of question, you really don't have to simplify. If you have to find the sum of the coefficients, what it means is that you have to find the sum of like everything, basically, just the numbers. So on the top, I'm from this question, we just have a 4, a 3, a -1, right? A 4, 3, -1. And then we have a 1, a 4, and a -2. So this 1 could cancel out with this -1, and we could just add everything else. So 4 plus 3 plus 4 plus -2, that's 7, 11, and 9. So your answer is 9. It's basically just that simple. If you want to simplify it to get the exact terms, it would just be 4m cubed plus 4m squared plus 4m, and then actually plus 3m squared plus 3m, and then minus 2, I believe. But it's basically that's that simple. But if you want to speed up the time, that's usually how you do it. Number 2, in the given factor tree, determine the sum c plus m plus p plus w plus k. So we know that 1260 divided by 30 is equal to c. So we just need to divide that out. So since there's zeros, I'm just gonna take out the zeros. So it's 126 divided by 3. So that's just 42. So we know C already is 42. I'll just write out the chart right here, so it'll make more sense. So 30 and 42. Okay, so we know 30 makes it M and P. We don't know what M or P is, but we know that M is 2 times 5, so that's 10, and that makes that 2 and 5. So if this is 10, then this has to be 3. And we know that 42 makes W and 7, so W has to be 6, because 6 times 7 is 42. And then 6 could be split into a 3, right? So K has to be equal to 2. So we had to add up a 42. We had to add up a 10, a 3, a 6, and a 2. So that together, that's 52, 55, 51, and 52, 55, 61, and 63. So our answer for number 2 is 63. So far, pretty simple for the first two. Number 3, let this function equals 3x minus 4y, or like equation. Determine the value of 3 of that equation and then 2 of that equation again. Right? So we do the parentheses first. So 2, this function 5. So that's 6. 3 times 2 is 6. And then minus 4 times 5, which is 20. So minus 20. So that's equal to negative 14. Okay, so we have 3 and then that function negative 14. So 3 times 3 is 9. Negative 14 times negative 4, that's 56. So 9 plus 56 is 65. And that's your answer for number 3. Okay. Now number 4. Determine the value of x such so that 8x minus 2 is equal to 9 plus 7x. So 8x, to write it out, 8x minus 2 is equal to negative 9 plus 7x. So to do it pretty quickly, minus 7x here, and then plus 2, then plus 2. That makes the x. That cancels out, and that makes negative 7. So your answer is already done because that's just the value of 7 right there. So x is equal to negative 7 pretty quickly. So the first 4 questions usually pretty simple. Or so. The first page is usually simple, so it's like 1 through 7. Okay. Number 5. 5x squared plus 25x plus 20 is equal to k, and then x plus 1, and then wx plus 5. So what we could do here is, since they expand this out, basically we just need to simplify or expand this out, and then we should get the answer, right? So what could we divide all of these terms by? We could divide by 5. So 5x squared could be divided by 5 as x squared. 25x divided by 5 is 5x. And 20 divided by 5 is 4. And we could split this up as x plus 4 and x plus 1, right? X squared plus 1x plus 4x, that's 5x, and then plus 4, right? So this equation is equivalent to this. So we already know x plus 1, which is this term, and then wx plus p is this term, right? So our w is equal to 1, and our p is equal to 4. That means our k, which is outside the parentheses, is a 5. So what is the value of k plus w minus p? K plus w, that's 6, minus 4 is 2. So our answer for number 5 is 2. Okay. You don't have to be going this fast in the competition since you always want to always since you always kind of want to double check also. But generally, since I already did this, it's kind of simple, and I'll just teach you how I would generally do it quickly and most effectively. Sometimes effectively. Determine the value of the expression 2 parentheses x plus 3 divided by x minus 2 when 3 times parentheses 4 minus x is equal to 6, right? So we know negative 3, 4 minus x is equal to 6. So we divide negative 3 by both sides, so we know 4 minus x is equal to negative 2. So that means x has to be equal to 6, right? So we know x is 6, we'll just plug it into this expression. So 2, 6 plus 3 divided by 6 minus 2. So that's 9, and that's 18. And then this is 4. So simplifying that, that's 9 over 2. And that's your answer. So the answer for number 6 is 9 over 2. Okay. Number 7. The perimeter of the equilateral ABCD can be written as the expression kx plus w. Determine the order pair k plus kw, right? So our perimeter is just basically 2 times the length and the width. So one side of it is 4, and then it goes to negative 2, so that's a length of 6, right? 4 minus negative 2 is 6. So I already know one of them is 6. So now we just need to add this length, which is just x minus negative 3. So x minus a negative, and minus a negative is just positive, so plus a 3. And then we need to multiply by 2, right? Because we have this side and this side, we just multiply by 2, so it's this plus this plus this plus this. So we just need to double it. So then that is just x plus 9, and then multiply by 2, so x 2x plus 18. So our expression for our k is 2 and our w is 18. So then our answer is just 2 comma 18. And that's number 7. Okay. The first 7 should be pretty simple. No, actually works. Work on this. Okay, so now we have an exponent question. Determine the value of k when 3 to the power 2k times 9 to the power k times 27 to the power k is equal to 81 to the power of 2k minus 1. Express your answer as an integer or common fraction, okay? So to solve these questions, all you have to do is that you have to make it the same base. So since I already see 3 is the smallest, it's usually just going to be the smallest, so it's the 3. So we need to make everything into base 3. So we have 3 to the power of 2k times 9 is just 3 squared, so it's just 3 squared to the power of k times 27, which is just 3 to the power of 3, and that is raised to the power k, is equal to 81, which is 3 to the power of 4, and then raised to k minus 1. When you're have 3 squared to the power of k, right? What it really is just 3 to k. You just multiply them. So in this case, it's just 3k, right? Etc. Which you could also do for this one. But when you're multiplying exponents, I'm multiplying like exponents with the same base, like they're both threes over here. That's why we make it all into the same base. You actually just add the exponents. So it'll be this 2k plus this 2k plus this 3k. And that's equal to 4 times the 2k, which is 8k, and then 4 times the negative 1, which is negative 4. So this is 7k is equal to 8k minus 4. So we know k is equal to 4. And that's your answer for number 8. Basically just that simple. Okay. Joe's school's grades on a Joe's school grades on a normal 4.0 scale with all courses weight the same. That is, A is equal to 4 points, B is equal to 3, and so forth. After taking 15 courses, Joe has an exact grade point average GPA of 3.2. She takes one course in summer school and gets another A. The following semester, she takes 5 more courses and then has a goal to raise her overall GPA up to at least 3.4. Determine her overall grade point average if she indeed accomplished her goal. Okay, and we had to round to a nearest hundred. So when they usually give this, basically you want to use your calculator. Generally, since this is a calculator contest, you might just want to use your calculator the entire time because it limits the amount of like work you have to do and the precision is better. So since you're already taken 15 courses, uh, because to calculate averages, we had to have total over the amount, right? So what is our total? Well, so far, after taking 15 courses, we have an average of 3.2. So the total is 3.2 times 15. I just put this in parentheses. So, okay, 3.2 times 15. And so far, we have 15 courses. Okay. And after she takes one more course in summer school and gets another A, so she gets one more course, and the total increased by 4 because that's an A. See, plus a 4. Okay, let's make this a little longer. And then the following semester, she takes 5 courses and has to raise her overall GPA to at least 3.4. So it's at least 3.4. So this is greater than 3.4. Greater than or equal to 3.4, right? And she takes 5 more courses. So she pluses 5. But we don't know the amount because we don't know if they're A's, B's, C's, D's, etc., right? Or just mixed between like some A's and some B's, some A, some C. We don't know. So we just put X as our variable for the total for how much she got for 5. So then using our calculator, we know that 15 plus 1 plus 5, that's 21. So 3.4 times 21, that's equal to 71.4. And then we have 3.2 times the 15 plus that 4, 15 plus 4, and that's 52. So we have 52 plus x has to be greater than or equal to 71.4. So x has to be greater than or equal to 71.4 minus 52. That gets you 19.4. Okay. So what is the inch? So since they say that determine her overall grade point average if she indeed accomplished her goal, right? So the maximum points she could get is 4 times she took 5 courses, right? And if she gets all full A's in there, that's 4 times the 5, right? Because she took 5 extra courses. So the maximum amount is 20. You cannot get a decimal amount because it's impossible, right? You can only get like 4 points, 3 points, 2 points, 1 point, etc., right? So technically, x can only be an integer. So the the smallest possible integer that could get greater than 19.4 is 20, because that's the maximum possible amount. So then you have to have x is equal to 20 and plug it in. So what is that answer? So we have 3.2 times 15 plus 4, which is our, oops, sorry, 3.2 times 15 plus 4. That is 52 on the top, right? So we have 52 plus that 20, because that's our x, divided by 21. So using our calculator, that's 72 divided by 21. That should give you a number rounded to the nearest hundreds. That's 3.43. And that's your answer. For number 9. Okay, so that might be a little bit longer just because it's kind of like a paragraph. Okay, number 10. The fraction x over 72 is greater than the fraction 3 over 5, right? So x over 72 is greater than 3 over 5. Determine the smallest possible value of x if x is an integer, right? So we just need to multiply 72 in both sides. So 3/5 times 72, put in a decimal, you get x is greater than 43.2, right? So the smallest integer that's greater than 43, that's 44, right? So your answer for number 10 is 44. Basically just that simple. Okay, number 11. Line L has the equation 2x plus 3y is equal to 18. Line M has equation 6x plus ky is equal to 28. And line N has equation 6x plus wy is equal to 15. Line L and N are parallel. Okay, so what I like to do is that when they give me equations is that I kind of draw a rough picture. So we have axes and x-axis, y-axis, right? So we have 2x plus 3y is equal to 18. So we have something like this. And it's given in this line that line L and N are parallel. So let's just call this L. And then N, right, which is 6 at x. So that's 2x is right here. So 6x is higher than 2x, so you're going to have to draw a little bit above. So let's kind of erase this because I need to scale it right. L, and let's say this is our other equation, which is N, because they said it was parallel, so these two are never going to intersect. And then M is perpendicular to L. So since L and N are parallel, that means M is perpendicular to both of these graphs. So M has to be somewhere around here-ish. It might be like over here. It doesn't really matter. It just needs to be perpendicular. Okay. And that is line um, M. Okay. So line L and line M intersect at P. So that's P. And line N intersects M at Q. And determine the length of PQ. So we need to find this length right here. Okay. So how I would do this is that instead of finding the points, there is a formula to actually find the distance between two perpendicular lines, right? Because if you put a perpendicular line, I mean two parallel lines, if you put a perpendicular line between two parallel lines, the distance that these 2 points, the particular line intersects the two parallel lines, there is a distance to do it instead of like finding the points and then calculating the distance from there. It's kind of, but like if you want to use points, that's fine too. But usually I would just use this equation. The equation is basically if you have two equations, which is ax plus by plus c is equal to 0, and you have another one called a dx plus I don't know, a b c d ey plus f is equal to 0. The the distance, if a and b and d and e, and they're like basically the same numbers, a equals b and and a is equal to d and b is equal to e, then basically we have f minus e and then absolute value. It kind of doesn't matter. And then you put the absolute value of a squared plus b squared, right? Or you could have d squared plus e squared since they're basically the same numbers. So this equation will give us the distance between those two parallel lines, right? So how to do this in using this explanation? We have what's our two parallel lines? It's L and N, right? So our L is 2x plus 3y is equal to 18. And our N is 6x plus wy is equal to 15, right? We need A and D to equal each other, but they're not. It's 2 and 6. So how we do this, we just need to scale this equation up by 3. So 3 times 2x is 6x. 3 times 9y is 9y. And then 18 times 3 is 54. Okay, so we don't need this. We only need this part of the equation now, right? So we don't know what w is, but since we already know that these two equations have to be parallel, that means w has to be 9. That's basically what it is, because basically this number has to be equal to this number, and this number has to equal to this number. That's what makes it parallel. So now we know our two points, we don't really need C and F. Where it kind of matters is that this is 15, this is 54. So we just have the larger number minus the smaller number. So I could keep it positive, usually. You can have 15 minus 54, but you have to multiply -1 to make it positive. So overall, just find the distance between these 2 points. And then on the bottom, you just have 6 squared and 9 squared. And this is why we have it the same thing, right? So they're both 6s and both 9s. So we don't need get confused on which one to use, right? It doesn't matter which way you just put 9 squared plus 6 squared. It doesn't really matter. And then based on this idea, we have 54 minus 15. That is 39. Okay. And then 6 squared plus 9 squared. That is 117. Square root 117. Okay. Let's move this a little over so we get a little bit more room to work with this. Because we need to simplify now. Okay. So square root 117. If you kind of square root of 17 is just basically 3 squared times 13. So on the bottom, we have 39 divided by 3 square root 13. That's 3 square root 13 is the same thing as 117. And now 39 divided by 3 is 13. 13 over square root 13. Now you multiply the top and bottom by square root 13. So this thing, so on the bottom, that would be 3 times square root 13. Square root 13 times square root 13 is 13. So then this 13 divides by this 13, and all you have left is square root 13. So the simplified answer is square root 13, and that's your answer. So let's write it a little nicer. Okay. So this is your answer for number 11, square root 13. It might seem like a lot of steps and a lot to remember, but it's really simple. All you have to do is remember is to take the difference between those two values, what they equal to, and then divide that by the square root of that common one, which is 6 squared plus 9 squared. I know that sounds like a horrible explanation, but if you keep doing it, it kind of makes sense. And it gets repetitive and it's not really that hard to do afterwards. Number 12. Determine the units digits for the number 3 to the power of 2017 minus 2 to the power of 2016. Okay, so if you kind of think about it, let's say we have 3 to the power of 1. What is that? That's 3. What's 3 to the power of 2? That's 9. What's 3 to the power of 3? That's 27. 3 to the power of 4? That's 81. 3 to the power of 5? That's 243. 3 to the power of 6? That's like 729. 3 to the power of 7? That is, I actually don't remember. 729 times 3. We get 82187. 3 to the power of 8 is 6561. And then 3 to the power of 9, 19683. So the reason I wrote all this out is that you kind of see a pattern. If we keep track of only the units digit, we have a 3, right? We have a 3, 9, 7, 1. And then you have another 3, 9, 7, 1. And then you start again, 3, right? So it goes in a pattern. So every single 4 times, it gets it repeats the pattern again. So 3971, 3971, 3971, right? So the pattern is for threes is 3971. So it repeats every single 4 times. So since this is going by 2017, 2017 divided by 4, right? So 2017, it repeats 504 times, right? Because 4 times 504, that's 2016, right? And then you have 1 remaining, right? So every single 4 multiple, that means every single 4 times, so 1, 2, 3, 4, that repeats the 3978, and then 5678 repeats 3978, 71, I mean, and then 9, 10, 11, 12, 3971, which is basically, so it keeps going like that until at the very end, that's all that we care about. So at the very end, it has only 1 left over. So at the very end, that means it's this one, right? Because it goes 1, 2, right? Because if it's raised to the first power, raised to the second power, raised to the third power, raised to the fourth power, raised to the fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, right? So if the last one remaining is right here, 2017, then it's gonna be unit digits of 3. Okay? So 2017, the units digit is 3. Now we have 2. So what's the pattern for 2? 2 raised to 1 power is 2, 2 raised to 2 power is 4, 2 raised to 3 power is 8, 2 raised to a 4 power is 16, 2 raised to a 5 power is 32. Okay, so we kind of see the pattern. Well, 2 power 6 is 64. Okay, we kind of see the pattern again. It's 2, 4, 8, 6. And then 2, 4, right? And then it's got to be 8, 6. So a pattern repeats again in like the same amount of multiples, but the numbers are different. So for 2, every single 4 numbers is going to be 2, 4, 8, and 6. And it's going to keep repeating like that. So we have 2016. 2016 is exactly a 4 multiple. So since it ends at a 4 multiple, that means it has to end at this term, right? Because that's the last term, so the end of the 4 multiple, the 6. So we know that the units digit for this number, 3 to the power 2017, is a 3. And we know that the units digit for 2 to the power 2016 is a 6. So what's 3 minus 6? 3 minus 6 is gonna, the units digit for this number is gonna be a 7. So how do we know that? Because it doesn't matter, you have a bunch of like digits over here, because it's gonna be 3 to the power 2017 is got a really big number. So what you're gonna do is that, like usual in math, like if we have like, let's say 27 minus, actually, let's use an easier number. Let's say 22 and you're minusing a 5, right? You take away 1 here and that becomes 12, so 12 minus 5 is 7, right? So you do the same thing here. So we take away 1 here, so this 3 becomes a 13. 13 minus 6 is a 7. So you know your unit digit for this number is going to be 7. So you don't understand why this works. The answer is 7. It's just really weird to conceptually think about it. But once you see why, it kind of makes sense really well. All you have to do for these type of questions is that you have to find out what's the pattern for when the unit digits keep repeating, and then basically just do the arithmetic based on like logic. Okay, number 13. Mimi, I hope that's the name, purchased 200 pounds of landscaper stock of 500 pounds of gravel. This means she purchased K% of stock of gravel. Determine the value of K. Okay, so this is just a basic percentage. It's just 200 divided by 500. I see 2 zeros on the top and 2 zeros on the bottom, so I'm just going to cancel those out. So 2 divided by 5 is basically 0.4, which is also the same as 40%. So K is just equal to that 40. You don't have to write the percent. So your answer is just 40. Basically just that simple. Number 14. A pair of standard 6-sided dies are rolled. Determine the probability is either a 6 or at least either the probability of rolling either a 6 on at least one die or a sum of 6 on the face-up dice. Okay, so we have two possibilities. Either we get at least one 6, or we get a sum of 6. Okay, so how many combinations can we make with at least one 6? Well, we have two dices, right? So if we get a 6 the first time, oops, okay, if we get a 6 on the first dice, the second dice we could get a 1, and if we get a 6 on the first, we could get a 2, 6 a third, 6 a fourth, and 6, or if we get 6 on the first time, we either get a 1, 2, 3, 4, 5 on the second. Okay. And if we get 6 on the last, we could also get two 6s, but we can't get 6 and then repeat again, right? So if we get a 6 on the second time, we get a 1, a 2, a 3, a 4, and a 5, right? We're not going to write another 6, 6 because that's the same thing as this, right? So how much combinations do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 combinations for when it's at least one 6. Now it's a sum of 6. So how can we add two sums of 6? We can either have 1 and 5, that makes a 6, a 2 and a 4, or a 3 and a 3. Or you could reverse the 1 and 5, so you could make 5 and 1. And reverse the 4 and 2 is 4, 2. We cannot reverse a 3 and 3 because that's a 3 and 3, which is the same thing as this. So you cannot have that. So you can either get 2 on the first, like what does these mean is that you can either get a 1 on the first dice and a 5 on the second, or you could get a 5 on the first one and then 1 on the second, right? So how many combinations is there? 1, 2, 3, 4, 5. There's 5 combinations, right? So total, we have 16. So what's the total amount of combinations? Well, we have 6 possibilities on the first dice, right? Because we have 6 possible. We have 1, 2, 3, 4, 5, 6, right? It's six, a standard 6-sided dice has 6 possible combinations. So we have 6. How many possibilities can we get on the second dice? We also could get 6, right? Because it's 1, 2, 3, 4, 5, 6. So there's a total of 36 combinations, and we know 16 of them works. And just in case, there is no overlap between at least one 6 and a sum of 6, right? If you kind of look at it, there is no overlap. Because for if it's at least one of the dice is 6, that means the sum is already 6. It's at least a 7. Because the smallest is 1. So everything above is 7 or above. So the sum is going to be not a 6. So these are not going to overlap. So we know that's true. So the sum, so the probability is 16 over 36. And if you simplify it down, 16 divided by 4 is 4. 39 divided by 4 is 9. So your answer is just 4/9. And that's basically just number 14. A kind of intermediate slash simple probability question. Okay. Number 15. When solved for x, the equation 5x squared plus kx is equal to -6 has exactly one real solution. Determine the possible values for k. So the first thing I do is that I usually make it into a quadratic. So we have 5x squared plus kx and then plus 6, right? You move the -6 to the other side, and that is equal to 0. Okay, sorry about that. So that's equal to 0. So for it to be one solution, the quadratic form is negative b plus or minus b squared minus 4ac over 2a, right? So if this entire side over here is equal to 0, right? If this is equal to 0, it's negative b plus or minus 0, right? So it doesn't matter. The only reason it's going to have at least has exactly one real solution is because when this part is equal to 0. Because then you're not adding anything, right? Because if you had -1, let's say this is not 0 and this is 1, right? Then it's plus 1, right? Plus or minus 1. Negative b plus 1, and then negative b minus 1, right? So now there's two possible answers. But if we have 0, but if this is not 1 and this is 0, right? We have negative b plus 0, negative b minus 0, which is the same thing as just this simplifies to negative b and this is negative b. So it's the exact same solution. So there's only one solution, right? So all we need to do is to have the square root of b squared minus 4ac equal to 0. Okay? So using that idea, we know b squared minus 4ac. So, and that's equal to 0. So our b is k. So k squared minus 4. Our a is 5. And our c is 6 is equal to 0. Right? So we know k squared minus 4 times 5 times 6 has to be equal to 0. Because squaring both sides, that means k squared minus 4 times 5 times 6 is equal to 0. 0 squared, which is just 0. So k squared is equal to 4 times 5 times 6. So k is equal to the square root of 4 is 2. We cannot take the square root of the other ones because they're not perfect squares. So our answer is 2 square root 3. But remember, this is k, right? We square rooted. So we got to remember it's plus or minus, right? Because k could either be positive 2 square root 30 or negative 2 square root 30. But sometimes when you have these answers, you might want to plug it in to make sure that both of them work. Because sometimes there's extraneous solutions. So maybe the negative 2 square root 30 might not work. But the answer, you could just write down this, plus or minus 2 square root 30. And that's the answer for number 15. Okay. Number 16. The sum of four consecutive integers is 78. Determine the product of the smallest and largest of these integers. Okay, so consecutive integers means that it has to be like 4, 5, 6, 7, 8, right? It has to be consecutive. It adds 1 every single time, right? So for consecutive integers, if our smallest integer is x, that means the next one is x plus 1, then the next one is x plus 2, and the next one is x plus 3, right? So that's our four consecutive integers. Add them all together, that's 4x plus 6. and they said the sum was equal to 78. So we know 4x is equal to 72. That means x is equal to 18, right? So determine the product of the smallest and the largest. So if x is 18, the smallest is 18. That means the largest is x plus 3. So 18 plus 3 is 21. So 18 times 21 is going to be your answer. Who you use your calculator, 18 times 21, and you get 378. And that's your answer for number 16. Okay. Number 17. 3 liters of pure water are added to 10 liters of 63% acid solution. The new total solution is now K% acid. Determine the value of K. Round the value of K to the nearest hundreds. Okay? And you don't have to use a percent symbols, usually what this statement is. So, as we have for percentage, it's always going to be total. I mean, not total. It will be what the amount is over the total, right? So how we do this is that since they're measuring the percentage of acid solution, that means on top should be the amount of acid. So how many acid is there? Well, you have a 10% liter of 6.3. I mean 10 liters of 63% acid. So there's 6.3 liters of acid divided by how many liters are there? Well, there's 10 here and there's 3 here. So that's a total of 13 liters total of liquid. Okay. So what does that simplify to? 6.3, I mean, what does that use? Using your calculator, what would that equal to? 6.3 divided by 13, you get by 0.4846, 153, etc. Right? Since it's percentage, we gotta multiply by 100. So 46153. So they said round to the nearest hundreds, right? So we only need this much. So we only need the 48.46. And that's your answer for 17. Basically, just that simple. It's just like another average question, but just don't mistake it. You are not supposed to take the 63% of also that 3 liters. So make sure you read the question carefully because the 3 liters is pure water. There's no acid in there. And then you add 10 liters of 63% acid. So 6.3 of liters out of that 10 liters is acid, right? Okay, number 18. A and B represents values of x such that 15 less than twice the square of x. Okay, so we have 15 is less than twice the square of x. So twice the square of x, and then 15 less than that. And then 15 less than that, so minus 15. Okay, minus of 15 is equal to the opposite of x. The opposite of x means just negative x. Okay, so this is like a quadratic, so 2x squared plus x minus 15 is equal to 0. Right, so usually in this case, I kind of split it up. So we have 2x and x on this side. It's equal to 0. And how do I get that plus? So I know 15 could go to 3 and 5. 3 times 2 is 6. 6 and 5, that's a difference of 1. So I know that's right here. So this is going to have to be a plus 3, and this is minus 5, right? So 2x squared plus 6x minus 5x, that's plus 1, and then minus 15. Okay, so x is negative 3, and x is 5 over 2. Okay, so when A and B, so A and B represents the value of x. So it doesn't matter which one's A and B. We just know these two are going to be A and B. When A and B are plotted on a number line, determine the positive difference between them. So what's the distance between 5 over 2 and 3? Well, that's just 5 over 2 minus negative 3, which is just 5 over 2 plus 3, right? So that is just 611 over 2. So express your answer as as an integer or exact decimal. So 11 over 2 is just 5.5. And that's your answer for 18. Okay? And that's basically it. Remember to read. Usually, if you put a fraction, you're not going to get the points. You have to put what the contest specifies you have to put down. Number 19. A to the power 3 plus b to the power 3 is equal to 2000. A squared times b plus b squared plus a times b to the power 2 is equal to 400. And a squared plus b squared is equal to KAB. for all real values of a, b, and k. Determine the values of k. Okay, so we just need to find k right here. Okay, so usually when I see these kind of functions right here, oh, sorry, let me just right. So these kinds, right? What I usually know about these is that you kind of want to split them up into like these kind of like exponents. So how you usually do it is we're gonna have, instead of a cubed plus b cubed, we're gonna have a plus b cubed. Usually of how the contests kind of do these. So what does this expand out to? That's a cubed plus 3a, sorry, a squared b plus 3ab um, squared plus b cubed, right? So we already have a plus b cubed, which is 2000, right? That means we have these extras that we need to take out. So we need to just minus 3a squared b minus 3a b squared, right? So all we have left is these two terms, which is equal to 2000. Okay, so we know that's true. So from this point, what I usually like to do also is that if I see any like repeats, I like to like distribute them out. So we have a plus b cubed, and we see a 3 and an a and a b, right? So distribute that out. So we make a parentheses. So 3a squared times b divided by 3ab, that's just a. And do the same thing for this, 3ab squared divided by 3ab, that's b, parentheses, equals to 2000, right? So now we're going to do the same thing with this term over here. So we could divide a squared b plus ab squared by ab. So ab. So this would also be an a plus ab is equal to 400, right? Because a squared b divided by a, right? We have a squared b divided by an ab is equal to a, and then we have ab squared divided by ab is equal to b, and then that's still equal to 400. It's equivalent. I just distribute them out, right? So let's kind of move this over because it might be a little hard to understand what I'm trying to do. Okay. Okay. So now do you see what I'm trying to do, right? We have a squared, a plus b cubed minus 3ab, a plus b is equal to 2000, and ab, a plus b is equal to 400. So let's kind of add them together. So we add them together, we could get a plus b cubed minus 2ab, a plus b, parentheses, a plus b, is equal to 2400, right? Because these two terms are exactly the same. So we just add them together, right? So this is our final output. But we don't need that. We need a squared plus b squared is equal to kab, right? So what do we know of what this is, right? So can we see a term? This is why I simplified out, because now we could just divide the a plus b out. So we have a plus b times, right? We distribute that out. Um, let's make this a bigger parentheses. So then we don't get confused by what the parentheses is. So we divide a plus b out from a plus b cubed. So that's a plus b squared minus 2ab is equal to 2400. Okay. So, okay. So basically, we know we have a plus b times a plus b squared minus 2ab, right? So what we need to find is a squared plus b squared is kab. So where do we see, like, can we simplify this out, right? So we know if we had to make it a squared, we have a plus b squared minus 2ab, that is equal to a squared, sorry, oops, right? Oh, sorry. So basically, we know that we have, if we kind of look at this term again, right here, we have a squared b plus ab squared is equal to 400, right? So that's basically this one that we talked about earlier, right here. So if we substitute, if we divide both sides by ab, that means we get that a plus b is equal to 400 divided by ab, right? And now let's substitute this term into here, right? So that's 400 over ab, right? So remember that. So we have 400 over ab times, what does this simplify to? I mean, expand out to. That's a squared, and then plus 2ab plus b squared. And then we still have this term, minus 2ab. Let's see how nicely these two cancel out, because this is plus 2ab and this is minus 2ab in the parentheses. So these two cancel out, and we get a squared plus b squared, which is what we're looking for, right? A squared plus b squared equals kab. Oh, sorry about that. So we could simplify this entire thing to a squared plus b squared, and that is still equal to 2,400. Okay, so all we have to do is now a squared plus b squared is equal to 2,400, multiply by that ab, and then divide by that 400, right? So now we know a squared plus b squared is equal to 2,400 divided by 400, which is 6, and then we have the ab. So it's already in this form. A squared plus b squared is 6ab. So a squared plus b squared is equal to kab. So k is equal to 6. And that's your answer. So it might be weird because usually that's not how you like do math questions, right? You want to find like what's a and what's b, and then we can substitute it in here and then find out what k is. But usually for math competitions, what we would do is that we usually like to rearrange these equations to fit what the final result is going to be. And that's usually how it works. For competitions. But sometimes if you're able to find what A and B is, you could also do that. But most definitely, this is going to be in this contest 2017 for Algebra 1 Division A. This is going to be like the hardest question. Generally, what I think it is. At Burger Buy, 2 burgers, a large soda, and a fries cost $14. Okay, so 2 burgers plus a soda plus a fries plus one fries. Yes, plus one fries is equal to $14. And 1 burger plus one soda plus 3 fries is equal to $15. And 3 burgers plus one soda is equal to $16. Okay? So now we have to determine, actually, before we read the sentence, let's kind of solve what B, S, and F is. The burgers, the soda, and the fries. So since I already noticed that these already have 2, what I like to do is that I like to substitute the smallest into the largest equations. Okay? So, since I know S is by itself on all 3 equations, I like to like put them in. I usually never use substitution. I use elimination. So you multiply this side by -1. So that's negative 3ab plus a negative s equals -16. So you add this equation to this equation, right? You get negative b. The s cancels out, and then plus an f. -16 plus 14 is -2. Okay, now add this equation to this equation. So that's -2b. That's the s's cancel out, right? Because you want to cancel out the same variable. And then you have 3f. And -16 plus 15 is -1. Okay, so what we like to cancel out? Let's cancel out this -2 over here. So let's multiply this top equation by -2. Okay, Oops. Right? So my negative 2. So this would make to negative 2 times negative b is 2b, and then negative 2f, and then negative 2 times negative 2 is 4. So adding them together, that means f is equal to 3. So our fries cost $3. If our fries cost $3, then what does our burgers cost? Well, we just substitute it back in, right? So 2b, 3 times 2 is 6, so minus 6 is equal to 4. So b is equal to 10 divided by 2 is 5, so our burgers is $5. So now we can substitute both of these into one of our original equations. Let's say this one. So 2 times b, which is 5, is 10. Our soda, we don't know, plus our fries, which is 3, is equal to 14. So our soda is equal to $1. Okay, so we know our three quantities. We know S is equal to 1, B is equal to 5, and F is equal to 3. B is equal to 5, and F is equal to 3. Okay, let's clear this entire thing. We're really close to solving this. I just need room, and we don't need this part. Okay, so what's the price for 3 burgers plus 2 fries plus 2 sodas? We just need to substitute it back in. So B is 5, so that's 15. 2 fries, which is 3, so that's 6. And soda is 1, so that's a 2. So 15 plus 6 plus 2, that's 21, and 23. So your answer is $23, right? You could just write 23. And that basically covers all the questions for 2017 Division A Algebra 1 regionals. Overall, the questions aren't really that hard. Some of them are really simple, like these, and then some of them like takes a little bit more intuition, like number 19, which is like the hardest. But overall, it doesn't really it's not really that difficult for this year's. So what you need to know is just general formulas ish, right? And then averages and exponents, which is just some of the basics. Okay, thanks for watching, and I'll see you at the next math record.